Yeah, thank you. So, what is object-oriented programming, or what is OOP? OP, generally, imagine everything as an object. Imagine yourself as an object. Imagine a car as an object, a book as an object, and your cute puppy as an object. So basically, OP is just like object. It's all about objects. So OP basically helps us model complex systems by building or by treating real-world entities as objects within the programs. So we just said we are going to treat everything as an object. A car, a book, anything can be an object. House is an object, okay? So we are going to treat everything as object. So I'm insisting on the word we treat everything as an object so that we understand what is OP in a better way. So in OP, we try to simulate, we try to emulate, we try just to simulate real world scenarios into objects when it comes to programming. In OP, we have classes, things called classes. We are going to see what are these things, we call them classes. We are going to see what are attributes, or what are these things we are calling attributes. And in brief, attributes are just characteristics of objects. Then there are methods or the actions of these objects. For example, using the three terms, classes, attributes, and methods. So let's break down a car. A car is an object. So it's a class, it's a blueprint. We already know what we are talking about. It's a car. A blueprint is just like a plan. We already know what we are talking about. So we are talking about classes, blueprints. So a car is a class, okay? Then attributes are characteristics of a car. What are the characteristics of a car? A car can have the shape of the car, the model of the car, BMW, Volkswagen, all those kind of characteristics. It's color red. All those are characteristics of a car. Then methods are their behaviors or actions of which a car possesses or a person has. So what are these key concepts now when we transform that into programming? Classes are just blueprints or prototypes, like a recipe. That's just an example. What is an object? An object is a specific instance of a class. And that when you are going to write the code. Then we have attributes. Attributes, we say, are characteristics or properties of an object. Characteristics or properties of an object, just like color, just the same way we say the car, the color, type, model, shape, all those kind of things. The size of the car, the weight of the car, those are characteristics. So attributes are just characteristics. Methods are actions or behaviors. Actions or behaviors that an object has or can basically perform. And using the example of a car can drive, right? A car can drive. So that's a method. So using all that definition by taking OP or treating OP as an object. So we know object as characteristics that are attributes, as methods, so those are behaviors. Then as a blueprint, we know what we are talking about. Okay? I'm going to use that for us to understand what we are talking about when it comes to these concepts. So we can look at an example here, then we try to understand this OP thing. So we try to understand this OP thing right here. So we define a class of a car. We assign colors as the attributes. Then we pass the methods here, or the behaviors, or the actions of that particular car. So with that example, we are going to write this example and then we understand better what are these examples. We are just going to write our own code and then we understand better about. So let's just go straight and create. Oops, I just opened my Cursor AI. No way. I need this. So in the meantime, I can comment this code. We don't want to execute this code. Just like this. Yeah, there you go. Now here is where we are going to create our car, or we are going to create our OP. Now, you already know we are talking about objects. When you talk about OP, we are treating everything as an object. A person, a car, a book, house, whatever item we are talking about, we are going to treat them as objects. So when you are talking about OP, we talk about classes. You know the way we define functions, like function name, something like this. Now, OP is the opposite of function. No, it's just another way of writing a function. When we are talking about OP, it's just another way of writing a function. Now, we don't need this. We can comment this. We don't need this. So we define class. Class. Today we are saying we are going to find our daddy a girlfriend. Let's say daddy's underscore girlfriend. So we are going to find daddy's girlfriend here. So we can just call this JS daddy's girlfriend here. So we know, let's just go back to our programming right here. So when we talk about classes, we talk about the blueprint. So what are we talking about here? We already have the blueprint. The blueprint is this kind of girlfriend we are talking about. We already know in our mind we are coding an object that we are calling a girlfriend, okay? So with that example, we go further. It's a blueprint. It's a blueprint. We go further and create attributes of that particular object that you're talking about. So in this example we are talking about, we are going to give this girlfriend some attributes. And what are attributes? For reference, what are attributes? They are characteristics or properties of an object. What characteristics can we give our girlfriend? I just want to see examples. What characteristics do you think we can give our girlfriend here? Oops, I think my screen is freezing. Just a moment, guys. My screen is freezing. My Zoom is freezing. Just a moment. Let's try to be a little decent. I'm just waiting for your crazy answers. No. No. Yeah, we have someone here who just gave good examples. Who was this? I'm waiting for those examples. I'm looking for one example. I'm waiting for that example. There we go. We know the skin color. We know the skin color for this, that is girlfriend we are looking, is is a brown skin. It's a brown skin, right? We are looking for this example. What other property can we give to this girlfriend? Let's say I prefer young girls of around 45 years. Those are young girls, I prefer them. I'm seeing your example, I can see you. No, those are just young girls, age of 45, you know. Of course, she should be shorter than me. And her name is, can you give me a name for this girlfriend? I'm waiting for that name. I'm waiting for this. I'm waiting. There we have it. There we have it. There we have it. Someone just gave us JS Mommy. Someone just gave us this name here. So now, don't overthink, guys. So this is the example. We have a class. It's a blueprint. We know we are looking for a girlfriend, right? Skin color is brown skin. Very young, 45 years old. Height of 5.4. And her name is JS Mommy, right? So what have we achieved according to our programming here? Someone is recording. You're going to report me to our manager? No, someone is saying that is recording the examples, will report me. Okay, so what are we remaining here? So what have we done? We have done the class. We have done the attributes. And we have done, no, we have not done the methods yet. So what have we done? We have done the class, the attributes. So we want to pass the method to our girlfriend, okay? So what is the method? Action or the behaviors of this certain girlfriend, okay? So over here, we are going to define the behaviors as let's call her JS Mummies. No, JS Mummy. Let's just give it JS Mummy, any name of our choice right here. And we just write a normal function. And say, yeah, JS Mummy is a great cook. She is a great cook, of course. She has to know how to cook some misheveve. Yeah, she has to know how to cook, of course. So let's just go back to our example here. So we have to pass a method. So what is the method? A method is an action. A method is an action or behavior that an object can perform. So it's a method. A method is just a behavior or actions that object can perform, okay? So what have we defined? We have an object, we have our attributes, and we have the behavior or the functions that this girlfriend will perform, okay? Now, let's go back to our example of a function. If we write a function like this, we expect for it to execute, we expect to call our function, right? We expect to call our function. For example, in that example, we expect to call our function, right? Of course, we expect to call that function. So by treating this as well as a function, we need to call it. For it to work, we need to call this particular function, okay? So how do we call, or how do we call, or how do we execute this particular class that we just defined? It's very simple, very simple. Referencing from this example, So I'm feeling lonely. So I want my girlfriend to come over, okay? So what who am I calling, who am I texting to come over and pay a visit? We are going to call this girlfriend to come over and pay a visit, okay? But maybe JS daddy has so many girlfriends. For example, I'm just saying, it's just an example. You are going to call this girlfriend to come over. But from the list of contacts, I have so many, okay? I have so many. So what we are going to do here, we can just print, we can tell this girlfriend to come over, but we can reference a single girlfriend, and that is specifically JS mommy, okay? So what have we done here? We have gone to this girlfriend, which we don't know her name yet. We passed all the attributes of this particular object, and we defined the function, or we defined the behavior or the actions that should be performed, right? So in this example, we defined a variable in which we said come over, then we called that girlfriend right here. So we just assigned this one to this one. So, but I want to print come over JS mommy dot, this one is wrong, dot name, okay? Dot name. So let's run our code and see. Perfect, there we go. We have printed out the name of this particular character we are talking about. So we have printed out this character we are talking about. And I think with that example is a very perfect example for us to understand. I can see you guys are so active today. Why? Someone is saying send the code here. Someone send the code. You want to use my code? No, write your own code. Write your own example. Write your own example. Monica, I can see you. Create your own function and call your own boyfriend. You are not going to use my example. Kevin, you can't relate. That's why I'm using this example to make you feel bad. You can't relate, Kevin. You can't relate. I just want to make you feel sad today. But if you don't want to feel sad, make yourself happy, create your own girlfriend just like me. Wow, I can just see. I can see. Only ladies are telling me to repeat. They just want the example. Repeat. What am I repeating? Just telling me to repeat. Repeat what? Yours is giving error. Someone say their code is giving error. Why? Why is it getting error? Maybe you have called the wrong girlfriend. Maybe you have called the wrong girlfriend. If your code is giving error, just know that you have called the wrong person. Just call the next one. It's simple, as simple as that. Okay, let me just show the code again. Just check. So I saw someone post an error some few hours ago. they were saying that their code is not running. So there's thing that is serious, that is indentation in Python. So once you are done with the class, defining the properties and also the method, if you want to call this variable, make sure that they are in a straight line with where your class starts. So it's on the far left. It should not be inside the same block of code. So make sure it's on the left, far left. Make sure that it's on the far left so that it's not inside here, because if it's inside here, you'll get some weird errors. So let me just copy the code in case you want to have the code. In case you want to have the code. Line 8 is giving errors. Line 8, 1, 2, 3, 4, 5, 6. The come over thing here is giving errors. I know why. I know why it's giving errors. So in case yours is giving errors, now let's say, for example, this is a lot of code, and I want to create a sense of belonging in this class. So what I need to do, I just need to add a parameter right here. You see, inside this function, you can give it self. We are going to see a good example of this self. In a short time, we are going to see a good example of how to use this self. But in the meantime, this self is very simple. This self basically means self refers to the instance of that class, and it's used to access attributes and method within a class. So that self basically refers to, it's just like a pointer which refers to an instance of a class the method is in. Or in other words, refers to an instance of the class, and is used to create, or is used to access attributes and methods within a class. So I want to explain it further. So in this example, if we self, we mean, let me just go back to the example of the car. The car makes more sense. So here, in the car, so what did we call? Someone said, yeah, I just want to give the example. So I want to get the error that you got. Let us just create our own error. For example, we wanted to call this. For example, you wanted to call this function or this method, but we know this method is inside this class of this class, right? So in case we wanted to call it, I'm going to run the code and see, maybe you are getting a similar error. Maybe you are getting a similar error. So what we do here is creating, we just add self. So what does self mean here? Remember that we are using this come over. This come over has been assigned to this class, okay? So we are saying come over dot JSMami, this one here, right? That's what we are calling. So this self creates a sense of belonging, or it belongs to that class. So I'm calling this JSMami, but I'm also referencing to this. So when I add self, tells me this JSMami method belongs to this class of a girlfriend. So that belongs to that class. So when we create self, just add self. Then when you call it like this, it will call now this one. It helps you access instances inside this class. So that's an example of that. Now, because I have my own girlfriend, I'm no longer lonely. So for those who are lonely, you only have 30 seconds to cry with this song. I was just listening to this song. Then I heard the music say something like come over. And then I just realized I used the variable come over. So I'm sorted. I'm sorted. I'm sorted. So next example. Next example. I can see you guys don't want to leave the session. I can see you're waiting for the next example. So for the next example, that is topic number 2. We only have 3 topics. Introduction, we are done. We are into constructors. Then we go to the final, that is OP principles. So what are constructors? What are constructors? Constructors, so with an example, every time you create a new object, you want it to have its unique attributes. So every time you create a new object, and we said, for example, a car is an object. So every time we are creating this object, we want it to have its unique attributes. Okay? You want it to have its unique attributes. So we use the constructor init method, the init method. The init method, we use the init method that will allow each object to start with a specific value. Again, every time we want to create a new object, let's assume that we are creating a new object. You want it to have unique attributes like color, model, etc. So we use the init method, and that will allow us, or will allow each object to start with a specific value. Let's go further. So what are instance variables? You are going to see these examples and we get the examples better. So instance variables are specific to each object and can vary across objects. We are going to see, don't worry. These are very simple terms. So don't worry. So for example, a car object can have different colors, models, and scale. So we can just reference an example and we are going to understand it better. We're going to understand better. So we can just use the example of a car. Example 2. Example 2. So we define a class of car, in which this class of a car, let's say we wanted it to have its unique attributes. Okay, so we use the def, something like this, for example, something like this. we use the double underscore init, double underscore. Then over here, we can use our variables. So our first variable will be self, and I will explain why self. We can use color, and we can use the model. Okay. Just like this. And now I want us to create an object with unique attributes. Once we are done with the example, you'll get it better. So we use the init method. That now will tell us this class has unique attributes whenever maybe we are calling it or we are using it. So we use the self dot color, in which is we assign that one to the color. So this is self dot color. So we use the self dot color. So we said with this example, we said self. We said why we are using safe as not self but safe. We use self because it refers to the instance of a class. It refers to instances or instance of a class, and is used to access attributes and methods within a class. That's why we are using this self right here. It will help us access the instances of this class that we have. And what are the instances? The instances, for example, is the color, and another instance can be self dot model, right? Self dot model. Now, with that example up to there, now we can create a variable, and we call it I just want an example that won't conflict with this. I can call it my car. My car is equal to that particular car. So what are we doing right here? So we just created a variable. Now that we assigned to this variable, to this class. In that class, we know we have two parameters that we have to assign to something. So that is red, that is color red, and that is, the model is BMW. So basically what I can do here is I can print my car dot color. So once I run this code, I can see the color is red. So that's how you create that example. So let's assume that I have two cars or several cars, and they are all inside this car. So for example, I can create car 1, and I can create car 2. And I want to share example here. So this one is white and is a Volvo. Let's just write a Volvo, just any random car model. So I want us to go to the definition so that I explain why we have all that. So every time you are creating a new object, you want it to have unique attributes like car, model, and color. Unique attributes. As you can see here, I have my car 1. Car 1 has unique attributes in which is color red and a model of BMW. But it's still a car. What if I have another car 2? But also I'm also referencing to this car class. So it has to have its unique attributes. And the unique attributes are white and Volvo. So if we try to print, remember that we are only using the same class. We are still using the same class. So if we print out color, if we try to print out car 2, example, if we try to print out car 2, then we can see color red and color white. So that means we have achieved this statement of having unique attributes. Even though we are referencing to the same class, every time we are assigning it, we have unique attributes. And that's how this example is basically is. Someone was telling us to build a side chick instead of building a car. No. African men don't cheat. Black men. Okay, so yeah, so that's example. Is it a double underscore before the init? Yeah, this is not a single underscore. If we put a single underscore, it's not the right way. So we use double underscore in both before and after. Before and after. So we use double underscores for that particular constructor. So we use double underscore. So someone is saying type car, type error car takes no argument. So just cross check if yours is like mine. So a car should have red BMW and it should be like this. Just cross check, maybe you have a small typo. Cross check, maybe you have a small typo. Either you have a small typo, someone say that they forgot the double. Just check if you have a typo. So I want us to go to the last topic of the day, and that is principles of OOP, OOP principles, OOP principles. Already, you have written the first example. So yeah, you have written the first example, but I'm going to explain, So, in OP principles, we are going to look at 3 principles. That is inheritance, polymorphism, and encapsulation. Inheritance, polymorphism, and encapsulation. So that's what we are going to look for these basic examples. OOP examples here. Principles. So what is inheritance? From the word inheritance. Inheritance, just like human beings, we inherit behaviors, characteristics, or traits from our parents. Skin color, height, behaviors, all those kind of things, we can inherit them from our parents. So inheritance is still the same in programming. So we can inherit classes, or classes can inherit attributes and methods from other classes. So basically this helps us reduce code repetition. This one will help us reduce repetition in programming. So we have said inheritance is the behavior of inheriting maybe characteristics, traits, all those kind of things from our parents. So who is inheriting here? We have the child and we have the parent. So we are inheriting directly from the parent. We can inherit everything, property, basically everything that our parents they have. Okay. So if we can inherit everything, so we are going to look at this example right here. So if we look at the mirror, if we look at ourselves at the mirror, or for example, we look at let's say at some point, let's say we are polygamous. It's just an example. Let's say we are polygamous. I have my first wife, my first girlfriend. I want my second girlfriend to have the same qualities as my other girlfriend. Why? When my girlfriend A is not around, my girlfriend B can come over. So what am I going to do here? For example, just an example. So referencing from this example, we have class of vehicle. Then we have everything inside that vehicle. Then of course, we have our second, that is car. Okay, that is car. So with that example stated, just a minute. So with this example right here, we can say, for example, we have class of JS, that is underscore G2, girlfriend number 2. In girlfriend number 2, just a moment, let me just comment this code. You see all these behaviors right here. We see all these behaviors right here. We can inherit all these behaviors by saying, oops. So we can say girlfriend number 2 will inherit or should have the same behaviors as girlfriend number 1. Imagine we have inherited all the behaviors right here. Imagine. That's it. Nothing more. We can inherit that just like that. We can just inherit those behaviors just like that. Imagine we are done with imagine we are done with that example. And imagine if we run this code, or this entire code, imagine it's going to execute with no errors. Why? Because girlfriend number 2 has inherited all the behaviors we have in girlfriend number 1. Basically, that's what inheritance is. Nothing complex, guys. Nothing complex. No, I've not confessed. I'm only 20. I'm 19. Actually, I'm 18 years old. I'm too young. No, I'm 17. I'm 17. Hey, Nicholas, I can see you. I'm 17 with a 45-year-old girlfriend. That's too young. That's too young, man. Wait, Vivian, you are saying I'm 27. How did you know my age? It's just a question. It's just a question, Vivian. I can see someone say, Auntie Vivian might be the JS mommy we are talking about. Vivian, you have a lot to explain to this class. Vivian, you have a lot of things to explain to this class. A lot of things to explain. How do you know my age? This is the code for the one who requested to see the code. This is the code. Okay, anyway, last example. Then we close the day. Last example. Then we call it a day. So we are talking about polymorphism. Let's talk about polymorphism and encapsulation. Polymorphism and encapsulation. Then we call it a day. Okay, so let's check the last example. That is polymorphism. Polymorphism. So polymorphism is a derived classes, or polymorphism are derived classes, or derived classes can behave differently from the same method inherited from the base class. So basically, with polymorphism, classes can behave differently from the same method they are inherited from. For example, we have the class of a dog. A dog can have a method of speak. And the method of speak, how does a dog speak? A dog woofs, okay? We can define another class, that is cat. Then, in this cat, we can still have the same method name, that is speak, okay? But a cat meows. With that example, we have a dog can speak. A cat can also speak, but differently. Different behaviors? Yeah, different behaviors. So, with polymorphism, we can loop through and see these different behaviors. So let me just go to the code that we just wrote with polymorphism and see how this basically works. So we have a class of a dog right here. A dog can speak. So a dog can speak, so can move. So that is the behavior that we want to show. And the cat as well can meow. But we are using the same keyword here, that is speak. So we expect it to print out the same output. But if we write a for loop to loop through these two different classes, so we say for the animal in the dog class and also in the cat class. So we are looping through. So you want to print out the speak. So in both of the two, you want to print out the speak method. So with the speak method right here is what we want to print. So with polymorphism, that means a method can have different behaviors. We are still using the same method name the same. So, but when we print out, they are going to print out different outputs. So when we run this code, we can see it can move, it can basically meow. So that's what polymorphism really is. So with that simple example, we can see classes can have different behaviors from the same method inherited from a base class. So we can see, even though we are using the same method, the output is different because that's polymorphism. That example, just that example, yeah. It says it's as simple as that. Very simple, as simple as that. So we check at the last one, that is encapsulation. Encapsulation. So encapsulation, this is the practice of keeping attributes and methods private or to prevent them from unwanted inheritance from outside the class. So as you can see, encapsulation, is the practice of keeping attributes and methods private to prevent unwanted inheritance. So we don't want any class outside our main class to inherit any attributes, any behavior, any method from our base class. So with that example, we look at this example, we already have the code, but we are going to explain encapsulation. What's up? Yeah, here we have it. So I'm going to explain what this code basically does. So we define a class that is secret stash. We create a sense of belonging with a init. That's what we said. It's only accessible inside here. Then we pass the self. So we pass the self dot chocolate. But as you can see, we are using double underscore before the chocolate. So we are creating a private attribute. We are enforcing it to be a private attribute. Because we are using the double underscore, then we define the variable name. So the chocolates, let's say that we have 10 chocolates. We define a function that is take chocolate. Take a chocolate. We take a chocolate. Of course, we pass the self right here. So if we have more than, if the chocolate are greater than 0, so of course we have more than, we have 1 and above chocolates. We know maybe in our basket of chocolates, we have 10 chocolates. Maybe we know we have 10 chocolates. So maybe in our basket, we know we have 10 chocolates, but we have enforced in our basket that it can't be accessed outside this class. So if we have greater than 0 chocolates, that means we are allowed to take a chocolate from our basket. So self.chocolate minus 1 chocolate. So if we take 1 chocolate from our basket of 10 chocolate with 10 chocolate, that means 1 chocolate has been taken. Or else, of course, because we know maybe we have 0 chocolate, we can say 0 chocolates, no chocolates left. Of course, we define a variable that is stash. Then we assign it to this particular class. Then now we can call this function. To call this function that we said it's a method, now we can stash dot take a chocolate. It's as simple as that. So I want to show you the difference. Remember that we have made these private attributes. Unlike polymorphism, this one was not a private attribute. That's why we are able to still define this one here, and we can still access it. Another example in a class. You remember this class here? This one is not private. That's why we were able to access the attributes and methods of this class outside the main class or outside the main function right here. That's why we were able to do that. But with encapsulation, once we enforce this one to be a private attribute, that means we can't create another class and try to access any method or any attributes of this specific class. And that's the basic example that we can give for this encapsulation. Is it a must you assign a class to a variable? Not a must, but it's a good practice. As you can see, our code is clean. Not a must, but not a must, but not a must, but it's a good practice. I said it's just a good practice. It's a good practice that we do it, that we access it. Please show the code for encapsulation. Let me just copy the code for encapsulation. Copy the code for encapsulation. Then I paste it here on the chart. There we have it. Okay, someone say, please summarize the three so that we end the session. We are ending the next 3 to 5 minutes. Okay, so a class is just like a normal, a normal function. It's just like a normal function. This one does not enforce so many rules. So we just define the class, then we pass the attributes, then we passed the method right here. With a simple definition, So let me just go back to our first example of what we said, what is an OP. OP we said are objects. Treat anything as an object. A car, a book, anything. Treat it as an object. After you treat it as an object, that means it has a class, it has a blueprint. So what are we talking about? We are talking about a car. It's a blueprint. We already know what we are talking about. A car has attributes and methods. The attributes are characteristics. Then the methods are the actions. So with this example, we have the blueprint. We are talking about this class. We have the attributes. Then we have the method right here. That's what a class is. Now, when we go to polymorphism now, imagine in classes, we were just using this particular method here. What if we wanted to create another class and use this method still? That's where we go now further to polymorphism. Now, when we change that, it's no longer a normal class. It's now in a form of polymorphism. It's on the principle of the polymorphism. So, in polymorphism, we can use the same method, but with different behaviors. So we have a cat, then we have a dog. We have a dog and a cat. So when you build on top of this, you can see this one is accessible and we can use it still here. But what if we didn't want to use it here? If we don't want to use it, we grow that, we take it to encapsulation. Encapsulation now enforces the rules. That is creating private attributes that we don't want them accessible anywhere outside this class. That's the difference between the three. And with that said,